Science uses a process called the scientific method. This does not pertain to non-scientific pursuits such as religion or ethics. The scientific method has predictable steps that are followed to arrive at scientific results. The first step is to make observations. Observations are how we watch the world around us, and these lead scientists to ask questions. Scientists then form hypotheses or educated guesses to explain what they observe. A good hypothesis can be tested with an experiment, and it can be proven false. Science does not prove things true. Experiments only provide evidence to support or refute hypothesis. Science is a process that can be used by anyone, not just scientists. When you pick up a flashlight that doesn't work, you make an observation. You might then make a hypothesis that it does not work because the batteries are dead. You can then conduct an experiment by changing the batteries. When that doesn't fix the flashlight, you'll need to make a new hypothesis and conduct additional experiments until your hypothesis is supported by the result of a working flashlight. A good experimental design will test only a specific variable that the scientist is interested in. An experimental group or a test group is exposed to the factor being tested. It must be compared to a control group that is not exposed to the factor. The control group provides a baseline for comparison. This ensures that any differences are due to the factor being tested. In an experiment, scientists tested if camouflage affects the number of times mice are attacked by birds in two environments. Scientists put fake brown and white mice in each environment. At the beach, white mice are the test group because they are camouflaged, and the brown mice serve as a control because they are not camouflaged. An experiment has an independent variable that is being tested. In this example, it is whether the mouse is camouflaged or not. This is the factor that scientists can change in an experiment. The dependent variable, or the result variable, is what the scientists measure. In this example, it is the number of attacks on mice. The dependent variable depends on the independent variable. The number of attacks depends on if the mouse is camouflaged. Data are the results of an experiment. Data can be presented in many ways, including charts and graphs. The axes of a graph describe the independent and dependent variables. The x-axis along the bottom is the independent variable, a 4-week study to try to lower blood cholesterol levels. The y-axis on the left is the dependent variable, the measured levels of cholesterol in the participants' blood. Average cholesterol levels of the participants are represented by the data points. Cholesterol was the highest in week 2 and the lowest in week 4. The standard error bars show the variance of the data. The average cholesterol in week 3 was 200. But some people were as high as 212, which was the average from week 2. Scientists use statistics to tell if this change in cholesterol is meaningful. Statistical significance means that the change in cholesterol levels is likely due to participation in the study and not just random chance. Scientists have agreed that if the probability is less than 5%, then the results are significant, not random chance. Scientific results must be published in scientific journals for others to read about. Scientific journals are more rigorous than publications on social media or in newspapers. Journals submit papers to peer review by experts and multiple rounds of revisions before they are finally published. The goal of science is to understand the world. Scientific theories are explanations that join together many well-supported hypotheses. Theories seek to explain why a natural phenomenon occurs. The theory of evolution explains how natural selection is the mechanism that causes evolution. While a hypothesis is just an educated guess, a theory is generally accepted as true. A law is a principle that summarizes a natural phenomenon. The law of gravity will explain what happens when you drop an object on Earth, Unlike a theory, it does not seek to explain why the phenomenon occurs.